Hi, students. Today, you're learning about how to represent motion on a position time graph, the relationship of graph slope to velocity, and learning how to calculate average velocity from a position time graph. So, your success criteria: I can describe how to draw a position time graph. I understand the difference between speed and velocity. I can explain how a position time graph shows the velocity of a moving object. I can show how to calculate the average velocity of a moving object from a position time graph of its position. So, your task checklist, we are on number one right now. We have already reviewed your speed lab, and you're watching this video on how to draw a line graph from speed lab data. Then you will be making your line graph with your speed data. So, you're listening to me now, and you can also do the work as I speak to you. You should have your lab back from me, and I'm also passing out or have given you some some graph paper. Okay, after which you'll use your data that you collected and that you made with your line graphs to make a flip grid verbally explaining your graph results. After you finish number three, you'll be handing in your line graph for a grade. And lastly, you're going to complete a matching activity on position time graphs. So, first of all, just to review the difference between speed and velocity. As we talked earlier, speed is position over time or distance something travels in a certain amount of time. There is no direction with speed. Whereas with velocity, it is a vector quality, okay, or quantity. You're going to be getting the direction that the object goes with its speed. So velocity is basically speed with a given direction. So just the difference between the two is that speed is a scalar quality, whereas velocity is a vector quality and quantity. All right, so let's take a look at your bar graph that you created. Now, this is just an example of one. Yours will look probably much different than mine because your data is different than mine because everybody had different groups that they were working with. But this is where you're going to, start. So the bar graphs that you created here are based on the categories of the modes of transportation. And whenever you show categories, you want to show your results with a bar. So you just showed basically the different speeds that your average group traveled when they got to 5 meters, 10 meters, and 15 meters. So now what we're going to do is we're going to take a look at your data again. And this time we're creating 4 line graphs on your graph paper. So where you want to get your information from, and if you want to highlight right now, you can. And the nice thing about this video is you can stop the video and you can, resume it when you're ready. So go ahead and highlight what you're going to be using today to do your graphs. So you want to highlight your average times for each of your Ivy levels. Okay, so that will be your first data that you collected, or that not that you collected, that you derived, which is your average times in seconds. Okay, that is what we are putting on the x-axis. So you have 2 pages of this. So go ahead and highlight all that right now. And as I'm doing this, I noticed that my lowest time is 2 seconds. Okay. And my highest average time was 51.3 seconds. So next, we want to take a look at the graph. So you want to set up your graph with a title and labels for your X and Y axis. So we are going to be graphing the average speeds, which is distance over time, on the modes of transportation. So go ahead and fill in your data, fill in your graph with that information. Okay, you always want to have your label including a unit of measure. And so we measured our average time in seconds, and the distance you guys went through the track was in meters. And you also want to include a key because we're going to be drawing 4 different lines, and each line should be represented with a different color or type of line. So in the example I'm going to show you, I'm going to do the IV hopping in green, the IV walking backwards in red. Um, Walking forward is going to be a dotted black line, and speed walking will be a solid blue line. All right, once you have your graph all labeled, now it's time to make up your intervals for the X and Y axis. So if we look here, we can see we've got 1, 2, 3, 4, 5, 6, 7, 8 big boxes. And then the little boxes inside, there's 10 of them. Okay. So each one of these big boxes can represent, since we have 7 um, little boxes and there's 8 big ones, 7 times 8 would be 56. So that means each tiny box is worth 1 second. So at the corner here would be 0 seconds. And right here, we're going to write 7. Whoops. 7. And then we're going to go up to the next box, and that will be worth 14 seconds. So we're just adding 7 seconds to each interval here. Then we go to 21 seconds and 28. We've got 35 seconds. You want to make sure it's always equal intervals because you don't want to have, you know, a small amount of time passing by. You want it spaced out appropriately. So, and you also want to use the entire graph. And since our largest average time was the longest average time was like 52, almost 52. We are really using up the entire graph as we should be. Okay, so that's the first step that you want to do. Let me show that to you a little bit in more detail so you can see it. Okay, so finish that first. And then we're going to do our distance. Okay, so you guys ran the track or walked the track. It was 15 meters total. So at each 5-meter intervals, a time was taken. Okay, and so the total distance that we traveled or you traveled was 15 meters. Well, let's see how many boxes we have going vertically. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't have 15. We only have 10. So we can't count each one as being 1 because we wouldn't have enough. We need to have at least 15. And we can't count, let's say, this one 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, because we really want to keep them, you know, in increments of 5 somehow because it's multiples of 5 because we have 5-meter distance, a 10-meter distance, and a 15. So what would fit here the best, I would suggest, would be every 3 boxes would be worth 5 meters. So we'll put 5 meters here, okay, at this line, and we'll go up to here. We'll count 3 more up. We'll put 10 and then 10 meters, and then we'll go up 3 more and put 15. And that way we're using the entire graph to show our distance. Okay, so 5 would go right there. Then we're going to go 1, 2, 3. I'm going to put another text box right there. 5, 1, 2, 3, 10. We'll move that over right there. And then the last one, we'll go up 3 more and put 15. 1, 2, 3, 15. So now we are using our entire graph to show our lines. So yours should look something like mine here. Unless your time, your average times were really much less than that, um, you're going to space it out according to, you want to be able to use the entire as much as the graph as you can. So let's say your average time, highest average time was, let's say, 8 seconds. That means that because there's 1, 2, 3, 4, 5, 6, 7, 8 big boxes, each one of these big boxes would be worth 1 second. So you just have to look at what your highest, time is and use that side appropriately. If you have questions, you can ask me and I can help you with that. But that's, everybody's going to have a different x-axis value based on their highest average time. But everybody should have your y-axis just like mine as far as your labels. All right, so the next thing we need to do is we need to graph our data points. So starting with hopping, which will be in green, we have the average time for this group to get to 5 meters was 17 seconds, exactly 17 seconds. So I'm going to use green. Okay, I'm going to go over to my graph. I'm going to go, I'm sorry, what was it again? 17. Okay. I'm going to go over 17. So that's 14 seconds, and 3 more would be 17. And I'm going to go up 5, and I'm going to put a green dot right there. And you can use pencil at first if you like. And then you can do the line in green, or you can do your points in green and then your line in green too. It's up to you. I don't like that. Let me do a circle shape. Okay. So 17, over 17, up 5. There we go. Okay. And then we're going to do the next point, 25.5, over 25.5, up 10 meters. So 21, 22, 23, 24, 25, and up 10 meters. 21, 22. And our last point was 51.3 seconds. So here's 49, 50, 51.3. Okay, now we're just going to connect our points with a straight edge. So make sure that you get a ruler starting at 0, 0. I'm going to go from 0, 0 to our first point. Make sure it's nice and straight. Then to our second point. And lastly, our third. One thing to keep in mind is the slope of the line indicates the speed, the average speed during that segment. So you can see the steeper the line, the faster the speed. And that makes sense when you look back at your speed values for hopping, 0.1 meters per second, 0.4, which is slightly higher, and then 0.1 meters per second. So clearly, this group on average went faster in the second segment here from 5 to 10 meters. Okay. So next, what you're going to do. Oh, and by the way, if you see a flat line on this graph, if we were to make a flat line right here, let's say to there, you should be able to know what that means. Think about it for a minute. If the slope of the line indicates the speed, the average speed in this case, of a person or a group of people, what would a flat line indicate? Well, if we went 15 meters and we didn't go any further, but time keeps on ticking, right? That should imply that that person is at rest. He's not or she is not moving forward or backward. She's just stationary. Another thing that I want to mention to you is what about if a part of the line looked, instead of that, let's say we had a line that did this. Okay. What that implies is that person went back to point of origin very quickly because this is a very steep slope here. So this person finished the race and then ran back to the start again to maybe perhaps do the second IV level, which would be walking backwards. So we didn't record that, but you should be able to, you know, figure that out based on the different slopes of the lines on a position time graph. Okay, so straight across indicates no motion. The person's at rest. If the slope is negative and it goes back down in distance as time goes by, that person is coming back to point of origin. So next thing you're going to do is you're going to do your Flipgrid. Okay. So go to Schoology and go to number 3. Use your graph to help you with your Flipgrid, the one that you just created. And then once you're finished with your Flipgrid, come see me or your teacher, and we will tell you